In this problem, we want to take a look at these two graphs of f and g, and also this defined function h, and we want to determine the following values. Okay, so we're looking at composition again, but this time instead of using a table, we're going to go ahead and use the graphs of them. So for the first one, if I'm looking for f of 1, what I need to do is first find what is the function f evaluated at 1. So I'm going to go over 1 and go up, and notice I'm at a height of 3. So that means this guy inside here is 3, which means this, I need to find f of 3. So I'm going to go over to 3 and go up on the f function, and I'm going to be at a height of 1. So this guy is equal to 1. Okay, let's go ahead and look at the next one. This is f at g of 2. So we're going to take 2 and plug it into g first. So we'll go to the g function and we'll find where 2 is, and we'll get that height value, which is 0. So this is f at 0 because g of 2 is 0. And f at 0 is at a height of 2. Okay, so this guy is equal to 2. Okay, let's do h of g of 0. So h of g of 0. So we're going to go ahead and plug in 0 into g first. So 0 goes into g, and we get an output of 2. So this guy is equal to 2, so now we have h of 2. And h is defined as x minus 2, so if I plug 2 into here, I get 2 minus 2, which is 0. And don't go looking for patterns. Don't say, well, f of 1 was 1, f of g of 2 is 2, h of g of 0 is 0, so f of h of 1 must be 1. It could be, but it might not be. So let's go ahead and check. So what we need is f at h of 1, so we take 1, and we plug it into h. And it looks like there's going to be a little bit of an issue here, so we might have to extend our lines. So I take 1, and I plug into h, and I get negative 1 out, so I need f at negative 1. And if you extend this line down, it looks like f at negative 1 will be at a height value of 1. Yep, so it did come out to be 1 here, but is that always the case? No, absolutely not. So be careful.